Hi, my name is Furkan Ali. Today we're going to implement local RAG, which means that you'll be able to run OLLAMA and uh, basic RAG system into your computer locally without using any API, which is computer OpenAI or any other system. So we'll be using OLLAMA 3, which is an open source large language model, and we'll be using the Nomic embeddings for converting your files or text or anything into the embeddings. Well, you can use any sort of embedding, but Nomic is the state-of-the-art embedding, and it is better than OpenAI embedding, which is closed source, and you don't have to pay for it. So let's begin implementing. And the best part is that the code is very small. It is less than 70 lines, and shout out to the YouTube. I'm gonna mention his name on my GitHub. Um, he did it. He's the original author, but I just changed the implementation, and I made it like slightly more easy, more convenient for the users. So let's start. Now I'm going to share my screen. All right. So I hope screen is not visible on the. Okay, so let's start. So this is the local rag.py file. We have only two files we need to concern about. Okay, first of all, what is OLLAMA? OLLAMA is an open source framework which you can use uh, to run large language models locally into your system without relying on external external large language model APIs, and it can also run on your CPU, so you don't need a GPU. Like you must have like at least 16 gigabyte of RAM, but you don't need to have a huge GPU. If you have a GPU, it will be best, but if you don't have, you can run it on your CPU. I'm running on my MacBook, which is M2 Pro, and it works pretty fine. And yeah, you make sure that you have at least 16 gigabyte of RAM. So we're gonna use that's all about OLLAMA. Let me show you how OLLAMA you install. You can go to the OLLAMA, and you can go to their I mean, pretty much good. You can click download, and after downloading, you can also install OLLAMA Python uh, library. They have but I think we don't need this one. So I have mentioned all the things that we need to install in the requirement.txt file. So you can just install everything from the requirement.txt except the OLLAMA. OLLAMA you have to install the way I showed you. Okay, so we have like two papers. One is attention paper.pdf and one is rag.pdf. First of all, let me show you. First of all, you have to upload as like all the other RAG models, RAGs, you have to upload the data to your data, and you have to convert the data into chunks so that you can feed those chunks into your large language model. And basically, how does RAG work? RAG is all about you don't pass all the information all at once into the large language model LLM, but you pass the specific information that you need. For example, you're asking about what, for example, there is a paper like such as the attention paper, and you want to ask just about who's the author of XYZ paper in this. Like there are references, right? So who's the author of XYZ thing? So your LLM should only focus on that part. It should not take whole the paper into its memory, into its context, and that would be like very uh, not a very robust way. So let's that's all about RAG. You just feed the relevant information into your LLM, and then it sees that information and it gives you the output based on that information. So we're going to use a sentence transformers library. We're going to use OpenAI, not their API, but their library. So we have, like, if you see this is like, I think less than 70 lines of code. We have two files, and this is like, how much is this? Oh no, it's not less than, but all right. So we have gaps as well, but it's really small as compared to the other uh, tutorials or implementations. And then we have like Okay, the original author used upload.py thing, which is based on tkenter library. But tkenter is the bullshit library I have ever seen. So please don't use it. If you want to use it, it's up to you. If it works perfectly fine in your system, you can go ahead with that. It's easy. It is a GUI based implementation. You can click upload and it will upload your PDF files or whatever. But if you don't want to use this thing, because if you're implementing this thing into your large huge system, then you don't need this thing. You can go with upload2.py, which is a very robust way. It's like you have like there are certain formats that it supports. It supports PDF, it supports TXT and JSON and docs and CSV. So you can upload, you can give like a upload any of these files and it will like process it and it will convert that into chunks. So you can see that in example, I'm uploading rag.pdf, which is a paper, and speech.json, it's a JSON file, and I'm uploading another paper. So you can have like PDF, TXT, JSON, docs, and CSV file. You can upload these sort of formats into this uh, code. And then it's just, you just have to pass the files name here, which you want your rag to convert into embeddings, and then you're good to go. So pretty simple. You don't have to do anything. Just come here, pass the files name, and it will convert that into chunks, which we will be feeding later into the LLM in the form of embeddings. And so we are not going with an upload.py. I'm not going to explain that. So it is self-explanatory, but if you don't understand, you can reach out to me on nowhere. LinkedIn. I was going to say LinkedIn, but I get a lot of messages on my LinkedIn. So uh, please, it's very easy. It's a self-explanatory thing. So yeah, but yeah, you can drop me a message. I mean, I'll try to reply. Let's come back to the local rag.py file, which is pretty simple. Let me show you how the output first look like. Python, let me first run. Okay, the first thing that you will do is Python upload to.py. You'll run this thing first. And once you run it, it's pretty fast. It will convert your things into, and we're saving all the data in the form of chunks into the vault custom.txt. You can save this thing into the what is that? The databases that are specifically designed for the for storing embeddings. I forgot the exact word, but you know what I mean, right? So anyway, this is you can see that it converted it into chunks, all the papers, and these are the chunks and all the data. So these are all the data into chunks appended, and these are all the chunks that we're going to convert into embeddings and we're going to pass into our local rag. And now let's go with the Python local rag.py. Let's run this thing. Now what's happened? Now the thing is that it's going to convert that vault custom.txt text into data into the embeddings, and then it will feed those embeddings in the form of chunks, relevant chunks into the LLM, whichever you're gonna query about. So if you're querying about we have this big chunk, and if you're querying about this specific part of the data, it will only feed that part of the data into the LLM with some context as well. So let's wait. Let's see. It's converting into the embeddings. Yeah, just ignore. You can see that it has converted all the data into embeddings, and now we have like ask question about your document. So let's say what is RAG? Let's ask what is RAG, and let's see. And this is the data it is feeding into the LLM. It is as a context. It is feeding to the LLM, and you can make it. I have given top six. It means that it's going to give six chunks. The larger the chunk number, the more the context knowledge it will have. But I think it doesn't matter. You can do it three as well. Three are also good. Yeah, I mean, like go with the three. Or you can do the testing yourself. And then like I got the response. Look at this. Retrieval, augmented real, retrieve and generate refers to a type of hybrid language generation model that combines a blah, 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 blah. So write model to retrieve relevant information from a large external knowledge source, such as Wikipedia, and then use that information to blah, blah, blah. So pretty good answer. Let's say, and it has a capability to do the back and forth questioning as well. So let's say if I didn't understand, well, what do you mean by, let's say, like, let's say we ask, what do you mean by, uh, what do you mean by question, blah, blah, let's say this, we fed this thing into the, and let's wait and see for the output. We're using Llama 3. Keep this in mind. So the latest and greatest open source model. Since we are feeding a lot, 6 chunks, that is why I think it is slightly slow. But if you feed less chunks, it will be fast. Open domain question answer QA is a task where a model is asked to answer a question from the internet or other publicly available sources. Perfect, perfect. That's what we ask about. In this context, open blah, 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 blah. Okay, that is perfect. That is very good. And this is how it's gonna work. Like you can ask any question about your data and it will instantly give you the answer about it. Let's quit. And you can see like it's pretty simple, right? Very easy to implement. And this is like for the coloring of, you can see the green and blue, and this is just the coloring part, and then you're opening file, and then top 3 and top K is like how many chunks do you want to pass into the LLM at a time. So we were passing last time 6 chunks, but now you can pass 3 chunks. And then we have OLLAMA chat, which is like, okay, one thing I want to tell you that the original author was using this one, but this is like a slightly good, not that good, but fair enough for the use case, most of the use cases. But this one is the latest and the most advanced embedding model. So I think you should go with that. If otherwise, you can go with this as well. You can try both of them. You just have to comment this line and like this, and then you have to uncomment this one. But I'm gonna go with this. It's running on CPU. The best part is it's running on CPU. This is also running on CPU. And then we have like, we're telling it that open wall custom.txt in which we have chunks, and then we're just converting that into model.encode means convert that into embeddings. Encoding means encode that into embeddings, and then we have like, we're visualizing the embeddings, and then we're giving the system message as well. You can see your helpful assistant, blah, blah, blah. And then we have like, so it's pretty simple, easy to understand code, nothing fancy here, small, and you can make it as advanced as possible. And what is the OLLAMA thing? So you can see like I have like, yeah, I'm using OpenAI frame library, and I'm passing Llama 3. So you can pass Mistral here as well. You can go to the OLLAMA documentation, and you can see the tag, the model tag. And let's say, let me show you, like, for example, if you want to use a OLLAMA Mistral model. So you can go here, and this is a tag. So you can go to the tags, and yeah, I mean, like you can copy which model. Wait a minute, I think go back, and yeah, first of all, if you don't have installed this model, you have to first run into your, like, you have to run like, where is it? So you have to run it like, instead of saying run, you have to say pull. So it will first download this model, and then you can run our code, which is like Python, whatever you are doing. And also, yeah, you have to change the name of the model as well. So this is for example, you want to use Mistral. So you're going to copy this thing, and you can either copy full of this, or you can just copy Mistral and go here and change it with the Mistral, and it will start. It's a Mixtral, not Mistral. So I will start using that model. That's pretty simple. And I think, if I'm not wrong, you can also use like, you can, like, for example, if you replace it with Mistral, and then you can specify a tag here as well, like latest, or 8 by 7B, 8 by 22B, 22 billion parameters, and like you can specify a tag here as well, and it will use specifically that model. So yeah, that's the detailed implementation of this thing. And then as I was, and you can, the Cohere is a very So let's say Cohere, where is the database of, you know what? I forgot the name, vector data, vector database. So fucking horrible. I forgot the name. Vector databases. So we need it's crazy. So you can store your data into vector databases. You can see we're saving the data into vault custom.txt file, but that's not the optimized way. If you're gonna deploy this thing into production, you should use, well, you can go with this as well if you don't have a large amount of data. But if you have a large amount of data, you should go with the vector databases. You can use Cohere, which is open source option, Cohere vector database, and and you can use LangChain library as well. Like you can make it as advanced as possible. LangChain for like telling it when you're chunking data into small pieces, make sure that you don't break the word. You chunk when the sentence ends, which is full stop, or like this. You can specify the conditions of chunking as well using LangChain. So you can like do a lot of customized implementation, which I'm not going to go into detail right now. And apart from that, um this is one thing. And what is there anything else I'm leaving behind? So yeah, this is the end of the tutorial. If you don't, I mean, you don't have to stick with me. That's all I explained. And I'm thinking if I'm missing something. I'm gonna push this to the GitHub, and I'm gonna attach the GitHub link into the YouTube tutorial. And so LangChain, and then vector databases. What else can do? Like I'm giving the most advanced options if you're like building a startup or anything, and then you can go with those options as well. I mean, if you're building a startup, you can reach out to me on LinkedIn. I can give you the whole framework as well. Like what is the advanced RAG system that you can implement in your startup? There are so many advanced RAG systems. Like this is, for example, instead of using this, what is that? Instead of using Nomic, instead of using mini LM embeddings, I'm using Nomic embedding. Uh, Similarly, you can optimize the code. You can like the most important thing is the chunking part. You have to like tell it like don't break into the word in the middle, break at the end of the full stop or sentence, or when there is a space between two words. You can define rules like this. And also you can make the chunks in a way that uh, like it takes the previous chunk context, like a last sentence of the previous chunk, and add it to the new chunk, the start line. So I mean, there are limitless possibilities. So yeah, I'm gonna end the tutorial. I think that was it. Last thing, that what is embedding? The most important thing is what is embedding. We were talking about embeddings. Embeddings are the like it's a the very naive definition is it's a tool, or it's a way to convert your textual data into semantic and keyword based information. When you convert something into embeddings, you can search about it using its context. What is which we call technical terminology, we call it semantic information. Semantic information mean that uh, the contextual information. For example, I'm saying that uh, like for instance, I say that I eat healthy food every day to keep myself fit. So, and I can this is one way to say something, and then I can say it like uh, eating healthy food is a good way to stay fit. Eating healthy, like I can change the sentence, and then I start finding the similarity. Then you will see that these sentences will have the most similarity between each other, because regardless of if the keywords are matching each other or not. So it takes care of the keyword based similarity and the contextual based similarity. That's it. Thank you so much. Bye bye.